In this example, we have C1005, H2010 reacting with oxygen to give carbon dioxide and water, or H2O. Just like the previous examples, we will rewrite the equation so that we can set random variables to them. So we have C1005, H2010 reacting with oxygen to give carbon dioxide and water. Let us now assign the random variables to each of these reactants and products. So for C1005, H2010, let's say we have A. For oxygen, we have B. For carbon dioxide, we have C. And for water, we have D. Next, we list the elements we have on both sides of the equation. So for the left and the right side of the equation, we have carbon, we have hydrogen, and we have oxygen. Now that we have the elements from the reaction, we can create equations for each element. So for carbon, we have 1,000 carbons on the left side of the equation with C1005, H2010. So we can say that we have 1005A, which is equal to, on the right side of the equation, we have only one carbon with carbon dioxide, so we can say C, or 1C. For hydrogen, we have 2,010 hydrogens on the left side of the equation with C1005, H2010. So we can say that we have 2,010A, and that will be equal to, on the right side of the equation, we have 2 hydrogens, and that is with water, so we will have 2D. For oxygen, we have 2 oxygen on the left side of the equation, so we have 2B. And on the right side of the equation, we have 2 oxygen with carbon dioxide, so 2C, and we have 1 oxygen with water, so we will have 1D. Next, we set one of the variables here to be equal to 1. So let's say A is equal to 1. Since we have one of the variables now, we can solve for the other variables. Let us look into the first equation we have for the first element, carbon. So we have 1005A being equal to C. Now we can rewrite this equation as C is equal to 1005A. And since we have our A being equal to 1, we can say that C is equal to 1005 times 1, which is equal to 1005. Now that we have the values for A and C, we have B and D left to figure out. So we can go on to the next equation we have for the next element. So for hydrogen, we have 2000A is equal to 2D. So we can rewrite this equation as 2D being equal to 2010A. Dividing both sides of this equation by 2, we will have D is equal to 1005A. And now since we know that A is equal to 1, we can plug that into this equation to give the value for D. So therefore, D is equal to 1005 times 1, which is equal to 1005. Now we have the values for A, C, and D. However, we have used up 2 of our equations, and we still have one more variable left to find, which would be B. So what we do now is that we will use our final equation, which is 2B is equal to 2C plus D, to figure out our value for B. Now so far we have A equal to 1, C equal to 1005, D equal to 1005. and we don't know what B is, and our remaining equation is for oxygen. So we are going to use this equation to figure out what our value for B is. So to start off, we have 2B equal to 2C plus D. We can divide both sides of this equation to give B equal to 2C plus D divided by 2. Now, we know the values for C and D. They're both 1005 over here. So we can plug that into our equation, and we will have B equal to 2 times 1005 plus 1005 over 2. And that would be equal to 3015 over 2. Now, once again, it appears that we have a fraction in one of our variables, which would be B. And the highest denominator we have among all our random variables right now is 2. So what we have to do is that we will have to multiply all our random variables by 2. So we'll multiply A by 2, and we'll apply the same to all the other variables. Now, once we multiply all our random variables with 2, we will have our new values for the variables. So we will have A equal to 2. We will have C equal to 2010. We will have D equal to 2010 as well. And we will have B equal to 3015. Now that we have whole numbers for all the random variables, we can substitute the random variables with these numbers as the coefficients for our equation. So we will have 2 C1005 H2010. We will have 3015 oxygen. And on the right side, we will have 2010 carbon dioxide, and we will have 2010 water. Our equation is balanced, and just for double checking, we can try the trial by error method if possible, if there's enough time. Otherwise, we can go over the methods and check to see if there's any calculation errors. Other than that, this equation is completely balanced. That's all for balancing equations. Thank you for watching.